We're going to turn our attention now to how we can take the derivative and apply it in a business or economic settings here. So first of all, just a few definitions we want to talk about. Total cost, that is represented by C of x. Marginal cost, we'll talk more about this later, but that is represented by C prime of x. Revenue, R of x. Marginal revenue, R prime of x. Your profit is P of x. And your marginal profit, P prime of x. So really when I say the word marginal right here, that just means the derivative of whatever function we're talking about. And one quick note here before we jump into what marginal cost or revenue or profit actually means is remember that the derivative tells us the rate of change. The derivative tells us rate of change. And that's one of those things that I kind of want you to, as soon as you see the words rate of change, your mind jumps to thinking about the derivative. Or if you see slope of the tangent line, you should be thinking about the derivative. But right now, rate of change is what I want to focus on. And if I want to interpret this idea of marginal cost or marginal revenue or marginal profit, marginal cost or revenue or profit tells us how that quantity is changing relative to production at a given production level. So what this really means is it tells us how our cost or our revenue or our profit will increase or decrease if we increase production. So here's an example. Let's say I am talking about marginal profit. Let's just take marginal profit here. And let's say I'm manufacturing perhaps 100 units per week, and whatever it is that I'm selling, my marginal profit is 50. This value right here, 100, that's my X, most likely my X value here. This represents my production level. And then this $50, really what I want to be paying most attention to right here is technically this is a positive $50. This is your rate of change of profit. Rate of change of profit. So if I wanted to interpret this quantity, if I wanted to talk about what exactly this whole statement says, I would say something along the lines of, at a production level of 100 units per week or per month. That would really just depend on the time frame we're talking about. We'll say per week. That's probably the most common one. Here in this case, our profit, our rate of change is positive, so our profit is increasing. So in this case, we would say profit is increasing by $50 per unit. So what that means is if I were to increase my production from, say, 100 to 101, I would see a profit increase of $50 per unit. Now, this doesn't tell the whole story, as we'll see later on, but it does give you an idea of maybe if you're trying to decide whether we should increase or decrease production. You can look at this and say, well, my rate of change here, my marginal profit is positive, so if I choose to increase my production, it will increase my overall profit. If I had ended up, say, with a negative 50 instead, so oops, let me fix that. If I had ended up with, say, a negative 50 here, then what this says is at a production level of 100 units per week, the profit is decreasing by $50 per unit. So that means if I choose to increase my production, if I increase, say, from 100 units to 101 units per week, my overall profit is going to go down by about $50 each time I do that. So that might be a case where you might say, whoa, hold on a second. We don't want to increase profit because we're actually going to be losing money if we choose to increase profit. And of course, in a business setting, there's all sorts of other things that you might want to consider rather than just is this going to increase or decrease profits? You would need to make your decisions on labor, available materials, things like that. So this is kind of the use case for marginal profit or marginal revenue or marginal cost. So now I want to talk about how this relates to exact cost or exact profit or exact revenue, but we're going to focus just on cost here. So let me section this off. The total cost of producing X plus 1 items here. So if I want to know, say, the total cost of producing, let's just say 201 units, I would say C of 201. I would take 201 and plug that into my cost function. So if I want the total cost of producing X plus 1 items, that would be C of, say, X plus 1. The total cost for producing X items then, so this is just one fewer, so if I go back to my example of 201, I would say, okay, well, my total cost would be 200 units. I would take 200 and plug that into my cost function. So the total cost of producing just the X items, not the X plus first item, would be just C of X. So here's my cost of producing X plus 1 items. Here's my cost of producing X items. Sometimes I'm interested in determining the exact cost of producing the X plus first item. So if I choose to increase production by 1 unit, what is that going to do to my costs? How much is that going to effectively cost me? And I can't just say C of X plus 1, because then that's going to tell me the total cost of producing X plus 1 items or 201 items. So I need to take away the previous X items or the previous, say, 200 items, whatever it is. So this would tell me the exact cost of producing the X plus first items. It says C of X plus 1 minus C of X here. So let's take a look at an example here. Let's see if we can use some of this information. We have a company that manufactures automatic transmissions for cars. The total weekly cost in dollars of producing X transmissions is given by C of X equals 50,000 plus 600X minus 0.75X squared. We're going to start off this problem by finding the marginal cost function. And whenever we see that word marginal from now on, that's another one of those words I kind of want you to tie together with the word derivative. Because when we say marginal cost, really that just means the derivative of the cost function. So I just need to find for this problem C prime of X. So let's see, derivative of 50,000 right here, I know that's just going to be 0 since it's a constant. Derivative of 600x, that should just be 600. And derivative of negative 0.75x squared, I'll multiply by my power, so negative 1.5x here. So there is my marginal cost function. It's simply just the derivative, and I can use my power rule to find that derivative. Part B says find the marginal cost at a production level of 200 transmissions per week. So here they're really telling me, okay, evaluate your marginal cost function when X is 200 units per week, because X was the number of units produced, or the number of transmissions produced in this case. So I'm simply just going to take 200 and plug that into my marginal cost function. So C prime of 200 is equal to 600 minus 1.5 times 200. So let's see, 600 minus, I should have 300 here, should be 300. And in particular, again, I want to pay close attention to the sign. It's a positive $300. Because when I get to the next part right here, part C just says interpret the results of part B. So I want to be able to talk about, well, what does this $300 actually mean? So I want to be able to interpret, what does C prime of 200 equals a positive $300 actually tell us here? So let's go ahead and interpret it. I always like to start off by referencing your production level, because that's going to be really important. That, without mentioning the production level, this number over here doesn't actually mean anything. So we want to make sure we mention that. So I'll say at a production level of 200 transmissions per week. So here we're talking about marginal cost over here. So I know we're talking about cost. Cost is, and from here on out, I want to use a word that describes change, right? And so if we're talking about something is changing, that number is either increasing or it's decreasing. So that's the type of language that I would like to see in your interpretation. Here we said we had a positive 300, so the cost is increasing by $300 per unit. So this is a way for us to look at how the cost is changing at this particular production level. So this looks like if I chose to increase my production, my overall cost would increase by about $300 per unit here. And just to see kind of the relationship between marginal cost here and exact cost, part D, I'm going to find the exact cost of producing the 201st transmission here. So if I want to find the exact cost of producing the 201st transmission, I'm going to take 201, plug that into my cost function. Let's actually just start with that. I know eventually I'm going to want to subtract C of 200, but I don't have these quantities yet, so I'm going to work these out. So C of 201, let me look at my cost function here. We said 50,000 plus 600x, so this is 50,000 plus 600 times 201 minus 0.75 times 201 squared. And so here, this one, it might be helpful for you to get your graphing calculator out. So let me do this real quick. 50,000 plus 600 times 201 minus 0.75, 201 squared. And I have, let's see, 140,299.25. So there is the cost. That's the exact cost of producing all 201 items, which is not actually what I want here, but I do need it. I need to take away the total cost of producing 200 units. Oops. So I'm going to take 200 and again plug that into my exact cost function. So 50,000 plus 600 times 200 minus 0.75 times 200 squared. And so let's do that math real quick. Times 200 minus times 200 squared. Here I should get 140,000. So that is the total cost of producing the first 200 transmissions. So if I want to find the cost of producing that 201st transmission, I know I'm going to take C of 201 and subtract C of 200. So I want to take here 140,299.25, 140,299.25 minus my cost for 200 units, which is 140,000. And here I end up with $299.25. So this is the exact cost of producing just that 201st unit, just that 201st transmission. And hopefully when you look at this, you can look at the answer to part C and notice, hey, $299.25, that is awfully close to that $300 per unit that we ended up with way back in parts B and in part C. So what this means here is if I want to find exact cost, because finding exact cost is a little bit tedious. I need to find this number, I need to find c of x plus 1, then I need to find c of x, and then I need to subtract them, and boy, that's a whole lot of arithmetic. So if I want to find c of, or excuse me here, if I want to find the exact cost of the x plus first item, I know I can take c of 201, or excuse me, c of x plus 1 minus c of x. I could do that, or I could say it's not quite equal to, so I don't want to say equal to, so I will say this exact cost, this is approximately equal to my marginal cost function evaluated at x. So here what we saw in this particular example is that if I want to know the exact cost of the 201st item, I can go and calculate that if I want to, or I can find the marginal cost function and simply plug in 200 and I'll get something at least relatively close, within the same neighborhood. It probably won't be exactly the same number, but it should be very, very close. In the next video, we're going to take a look at a very, very long problem. It's got a lot of parts to it, but we're going to talk about profit, revenue, costs, all of that good stuff. So take a look at that when you are finished with this video.